Assalamualaikum and salam sejahtera. Today we are going to present for our 5-axis machining project, and we are from group 4 to present for our lecturer TS Dr. Shahrul Azwan bin Sundi or Suwandi and TS Muhammad Shafiq. So this is our group members, starting from Muhammad Amirul Hakimi bin Mahmud. Second, me myself, Muhammad Ahmad Fahmi bin Armi. Third, Muhammad Ikhwan bin Zahaurin. And last one, Tanishwaran anak lelaki Balu. Okay, this is our organization chart, starting with Amirul, our leader, me myself, assistant leader, and second, Ikhwan for our designer, and last one, Tanish for our programmer. Okay, next we move to our objective. For the first one, to design the Ironman reactor using CATIA. Second, to fabricate the item using a 5-axis CNC milling machine, achieving precision and intricacy in the production process. And last one, to truly investigate and identify the precise process of machining required for the production of a specialized Ironman reactor. Okay, first we are going for our introduction. CATIA V5 is a robust CAD software extensively utilized in CNC machining and manufacturing due to its advantage tool and features. It enables designers and engineers to create complex 3D models and toolpaths for CNC machining, ensuring error-free designs with simulation and analysis tools. CATIA parametric modeling capabilities allow easy modification to design, saving time and effort when adapting to new machining requirements. The software compatibility with various CAD programs and CNC controllers enhance productivity and supports diverse CNC machining process like milling, turning, and multi-axis operation. Utilizing CATIA V5, the project aimed to design and build an Ironman-style reactor, showing cutting-edge design and engineering expertise through a visually striking and functional 3D model.
Good evening, my name is Tanishwaran. Today I would like to talk about our 3D modeling and process planning. Firstly, we face challenges with the initial plan 3D model, which is the Ironman reactor arc, because due to the limited stock size and unavailable end tools for the radius above the top of the arc reactor, so we edited the 3D model to meet the requirements. So we decided to ignore the top part and just machining the other area of the Ironman arc. Okay, next I'm gonna talk about process planning, which is firstly we have to understand our part requirements, which is dimension of the stock and tolerance and materials. The material we are machining is aluminum and other special features. Second, we have to select the appropriate CNC machine. In this case, we selected 5-axis machine and select suitable spindle speed and work holding. Now we have to choose our cutting tools, which cutting tools will be suitable for our machining processes. Then we have to develop machining strategy, which is sequence of operation, machining part, and efficiency and precision. Then we have to set up our CNC machine, which is create a CNC program and prepare cutting tools and fixture, and we just have to start machining. Later on, after machining, we have to inspect and quality control our product. We are like surface roughness and their measurements. Then we have to document the process, which is our process parameters, quality, and where we can be improved. That's all. Thank you.
warahmatullahi wabarakatuh. My name is Amir Hakimi. So today I would like to explain about the process for the machining on our product. So first, for the part operation, we already find it. We use a 5-axis machine, and then the WPS we use on the top of the product. Then we define the part and then the stock. So for the operation, we only use 3 types of process, which is roughing, profile contouring, and then lastly isometric machining. So for the machining roughing, we use the default setting, which is the machine tolerance is 0.01. Then the radial, we use the default. Axial, we use the maximum depth cut of 1.5 mm. Then the tool that we use is end mill diameter of 20. Then for the macro management, we use the default setting. For the profile contouring, there is a five process we use for this product. So first, as we know, we use the machining tolerance, and machining tolerance is 0.01. Fixture accuracy is 0.1 mm. Then for the step over, we use distance between part is 1 mm, number of pad is 1, and then the number of label also 1. We use the number of label. Then finishing as SM we skip. So go to the tool we use end mill diameter of 20. Then this section we do the outer layer of the product. Okay, so for the macro management, we only activate the approach and retract, which is from the plane. Then the second, profile contouring, also use the same parameter. And then the tool also we use a 20 diameter end mill. And for the macro management, we only activate approach and retract. And then you can see we settle down the top layer. Okay, and then for the profile contouring number 3, we use also the same parameter with end mill diameter of 20. And for the macro, we only use the same also, approach and retract. Then at the end, we use the type, the pad, the tool pad, the result of tool pad. Okay, and the profile contouring 4, also the same parameters with end mill diameter of 20. And then macro management, we activate the approach and retract also. And then the tool part we use for the outer layer. Okay, and then the last, profile contouring, also the same parameter with end mill diameter of 4. Then the parameter is approach and retract. Okay, the tool part is like this. We measuring the body of this product. Okay, for the isoparametric, we use the tool part style is one way. Radial, we use distance between part is 0.05. Then we adjust the start extension with 0 and end extension negative 0.1 to avoid the tool to collide with the check that is on the center. Okay, so for the tool, we use a ball mill diameter of 5. And then the macro management, we activate the approach and retract. And then the tool part, you can see this is a 5-axis strategies. It's tilting. Okay, and then the last process, isoparametric number 2, machining, we use one way also. Radial, distance between part is 0.1, and start extension is negative 0.2 to avoid the tool to collide with the body. Then the tool exists, we use the lead and tilt, and fix the guidance is fixed lead and tilt. Tilt angle is 45 degree. Okay, so for the tool we use a ball mill diameter of 5, and then the macro management approach, and then retract. Okay, so at the end, this is for the machining process for our product. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikhwan. My matric number is B0920102114. Right now, I will explain about discussion. This product requires a 5-axis CNC machine. So, machining duration of the product is 2 hours from 2:30 p.m. until 4:30 p.m. So, after that, size of product is round shape. Base diameter is 93.6 mm and height is 43.4 mm. So this product use only 3 tools such as end mill diameter 20, end mill diameter 4 and ball mill diameter 5. This product use 3 process, namely roughing, profile contouring and isoparametric machining. After that, roughing use 1 time only. For profile contouring use 5 times and isoparametric machining use 2 times in CATIA process. Lastly, starting with roughing process and end the process with isoparametric machining. After that, for the conclusion, the CATIA V5 and 5-axis CNC project has been transformative success, revolutionizing our design and manufacturing process. CATIA V5 advanced 3D modeling and simulation tools enable us to create precise designs with ease, reducing errors and improving efficiency. Generating toolpaths directly from the 3D model minimize manual programming efforts, enhancing productivity. With 5-axis CNC capabilities, we approach workpiece from multiple angles, achieving smoother surface finishes and tackling intricate geometries. This integration has strengthened our competitive edge, expand capabilities, and attracted new clients. We remain committed to exploring further possibilities and staying at the forefront of innovation in the industry. Okay, that's all from me. Thank you.